Hi. Do you know how scientists tell whether the results of research can be trusted? Well, they rely on 4 criteria: accuracy, precision, reliability, and validity. We'll explain what each term means and why they matter. Let's start with accuracy. In science, accuracy refers to how close your measurement is to the true value. Imagine you are playing darts. The bullseye represents the true value, and the dart you throw represents your measurement. If your dart lands close to the bullseye, that's accuracy. Let's say a mouse's true body temperature is 37.0 degrees Celsius. If your thermometer reads 36.9 degrees Celsius, it's close to the true value, so it is accurate. But if the thermometer reads 35.7 degrees Celsius, that's not accurate. Next up, precision. Precision refers to how close repeated measurements are to each other. Again, imagine you're throwing darts. If all the darts land very close together, that's precision, even if they're not near the bullseye. Let's say you measure the body temperature of the same mouse 3 times, and you get 35.3, 35.5, and 35.4 degrees Celsius. These measurements are precise as their values are close to each other, yet they're not accurate. If your measurements are close to each other, and their average is close to the true value, that is 37.0 degrees Celsius, your results are both precise and accurate. Ensuring accuracy and precision is vital in scientific investigations. Now let's talk about reliability. Reliability means the degree of consistency in scientific investigations. Precision, repeatability, and reproducibility are the 3 aspects of reliability. For example, Amy conducted 3 trials in her experiment and got similar results. That's precision. She then repeated the whole experiment another day, and her results were still consistent. That's repeatability. Ben, a student from another school, followed Amy's procedure and obtained similar results too. That's reproducibility. Only experiments that are precise, repeatable, and reproducible can be considered reliable. Finally, validity. Validity refers to the degree to which an experiment investigates what it is intended to study. Imagine you want to study how light intensity affects the transpiration rate in plants. To make sure your experiment is valid, you need to do 2 things. First, choose an experimental design that can best achieve your aim. A weight pottometer is a great choice, as it measures how much water the plant loses under different light conditions. Second, control other factors that might affect the results. Examples include wind speed and temperature. If these factors change during the experiment, you cannot be sure the results are due to light intensity or some other factors. To summarize, ask yourself these 4 questions when designing your next experiment. If you get 4 yeses, your experiment shows accuracy, precision, reliability, and validity.